Welcome to Module 7, Lesson 1, Understanding Non-Experimental Research. I'm Angel Reyes, and today we're diving into one of the most widely used approaches in quantitative research. While experimental research gets a lot of attention for its ability to establish causality, non-experimental research is actually what most researchers use in their day-to-day work. By the end of this lesson, you'll understand when and why non-experimental approaches are not just useful, but essential for advancing knowledge in your field. Let's start by clarifying what we're going to accomplish in the next few minutes. First, we'll distinguish non-experimental from experimental research approaches. This isn't just about what each method does, but about understanding their fundamentally different purposes and strengths. Second, we'll identify appropriate contexts for non-experimental designs. This is crucial because choosing the wrong research approach can waste time, resources, and potentially lead to invalid conclusions. Third, we'll analyze the strengths and limitations of non-experimental methods. Every research approach has trade-offs, and understanding these helps you make informed decisions about your research design. Finally, we'll evaluate when non-experimental approaches are most valuable. Sometimes non-experimental research isn't just a backup plan when experiments aren't feasible. It's actually the best choice for your research question. So, what exactly is non-experimental research? Here's our definition. Research that examines variables as they naturally occur, without manipulation or random assignment. Let's break this down. The key phrase here is as they naturally occur. Unlike experimental research, where we create artificial conditions and manipulate variables, non-experimental research studies the world as it already exists. We're observers rather than interventionists. Notice the absence of manipulation and randomization. These are the hallmarks of experimental research that we deliberately avoid in non-experimental approaches. Instead, we focus on existing variables and relationships that are already present in the real world. The observation versus intervention distinction is fundamental. Think of it this way. Experimental research asks, what happens if we change X? While non-experimental research asks, what is the relationship between X and Y as they exist? Finally, non-experimental research typically has descriptive, correlational, and predictive aims rather than causal ones. We're trying to understand, describe, and predict rather than prove causation. Let's explore the key characteristics that define non-experimental research. First, variables are studied in their natural state. This means we don't create conditions or assign people to groups. We study people, situations, and phenomena as we find them. There's no random assignment to conditions because there are no experimental conditions to assign people to. Instead, we might study naturally occurring groups or examine relationships within existing populations. We focus on naturally occurring relationships. These might be relationships between personality traits and job performance, between socioeconomic status and health outcomes, or between educational practices and student achievement, relationships that exist in the real world without our intervention. There's an emphasis on real-world context, which gives non-experimental research high ecological validity. What we discover is more likely to apply to actual situations because we studied actual situations. Large sample sizes are often feasible because we're not creating expensive experimental conditions or requiring intensive interventions. We can survey thousands of people or analyze existing databases with millions of records. When should you choose a non-experimental approach? There are a few different key situations where non-experimental research isn't just appropriate, it's necessary. First, ethical constraints often prevent manipulation. We can't randomly assign children to abusive households to study the effects of maltreatment, and we can't expose people to harmful substances to study their health effects. Many important research questions can only be studied non-experimentally for ethical reasons. Second, many variables simply cannot be manipulated. You can't manipulate someone's age, gender, personality, or cultural background. These are fixed characteristics that can only be studied as they naturally occur. Third, when studying naturally occurring phenomena, like the spread of diseases, the formation of social networks, or the development of communities, non-experimental approaches allow us to observe these processes as they unfold naturally. Population-level questions often require non-experimental approaches. If you want to understand national trends, cross-cultural differences, or large-scale social phenomena, you need methods that can handle the scope and complexity of these questions. Non-experimental designs are perfect for initial exploratory research phases when you're not sure what variables are important or how they might be related. Finally, practical limitations often make experimental control impossible or unrealistic. Real-world constraints of time, money, and logistics frequently make non-experimental approaches the only viable option. Let's dive deeper into ethical constraints, because this is one of the most important reasons why non-experimental research exists. The examples on this slide illustrate why we sometimes have no choice but to use non-experimental approaches. We cannot randomly assign people to experience trauma, even though understanding the effects of trauma is crucial for developing treatments and interventions. Instead, we study people who have unfortunately experienced trauma naturally. We cannot manipulate exposure to harmful substances like tobacco, alcohol, or environmental toxins. But we can study people who have chosen to use these substances or who have been exposed through their environment or occupation. We cannot withhold potentially beneficial treatments from people who need them just to create a control group. This is why many medical studies use non-experimental approaches to track outcomes over time. We cannot assign children to different family structures, but we can study how children in different types of families develop and thrive. We cannot manipulate socioeconomic status. We can't make people rich or poor for research purposes, but we can study how existing differences in socioeconomic status relate to various outcomes. The common thread here is that we cannot and should not create conditions that might cause harm, but we can study naturally occurring variations in these conditions to advance our understanding. Every research approach has trade-offs, and non-experimental research is no exception. Let's examine both sides honestly. The strengths are significant. High ecological validity means our findings are more likely to apply to real-world situations because we studied real-world situations. When you study job performance in actual workplaces rather than artificial laboratory tasks, your results are more likely to be relevant to actual workplaces. We can study variables that aren't amenable to manipulation. All those important individual differences and naturally occurring phenomena that shape human experience, but can't be experimentally controlled. Large, diverse samples are often possible because we're not constrained by the need to create expensive experimental conditions. This gives us better generalizability and more statistical power. Real-world context is preserved, which means we capture the complexity and messiness of actual life rather than the artificial simplicity of laboratory conditions. Data collection is often cost-effective because we can use surveys, existing databases, or naturalistic observation rather than creating elaborate experimental setups. And there are fewer ethical concerns because we're not manipulating or potentially harming participants, but the limitations are real and important. We cannot establish causation with the same confidence as experimental research. The relationships we find might be due to third variables we haven't measured or considered. Confounding variables are always present because we can't control the research environment the way we can in experiments. Selection biases are possible because people self-select into the groups we study rather than being randomly assigned. The directionality of relationships is often unclear. Does A cause B, or does B cause A, or do they influence each other? Alternative explanations always exist because we can't rule them out through experimental control, and we have less control over extraneous factors that might influence our results. Let's dig deeper into the causal inference constraints, because this is often the most challenging aspect of non-experimental research for students to understand and accept. The fundamental principle is that correlation does not imply causation. Just because two variables are related doesn't mean one causes the other. This is Statistics 101, but it bears repeating because it's so easy to slip into causal language when discussing correlational findings. The third variable problem is pervasive in non-experimental research. There might be unmeasured confounders, variables we haven't identified or measured that actually explain the relationship we've observed. For example, if we find that people who drink wine live longer, it might not be the wine causing longevity, but rather that wine drinkers tend to have higher socioeconomic status, which provides access to better health care. Temporal sequence may be unclear. In cross-sectional research, we're taking a snapshot at one point in time, so we can't determine which variable came first. Did depression lead to poor sleep, or did poor sleep lead to depression? Selection bias occurs because people aren't randomly assigned to the groups we're studying. People who choose to exercise regularly might be different in systematic ways from people who don't exercise, beyond just their exercise habits. We cannot rule out alternative explanations the way we can in well-controlled experiments. There are always multiple possible explanations for any observed relationship. Finally, reverse causation is always a possibility. Instead of A causing B, maybe B causes A, or maybe they cause each other in a feedback loop. Confounding variables deserve special attention because managing them is one of the biggest challenges in non-experimental research. A confounding variable is one that's associated with both the predictor and the outcome, creating spurious relationships. Let's look at some concrete examples. Age is a confounder in many health studies because age is related to both many health behaviors and health outcomes. If we find that people who take vitamins are healthier, it might be because people who take vitamins are also younger, and younger people are healthier for reasons unrelated to vitamin use. Socioeconomic status affects education outcomes, but it also affects many other variables: access to resources, family stress, neighborhood characteristics, cultural capital. So, when we study educational interventions, we need to account for socioeconomic differences that might explain our results. Selection bias creates group differences that go beyond the variable we're interested in studying. People who volunteer for health programs might be more health conscious in general, not just more willing to participate in programs. Historical effects occur in longitudinal studies when societal changes over time influence our results. If we're studying career development over decades, changes in the economy, technology, or social norms might explain patterns we observe. Measurement bias can occur when we measure variables differently across different populations, leading to apparent differences that are actually due to measurement issues rather than real differences. Here's something important. Non-experimental and experimental research aren't competitors. They're complementary approaches that work together to advance scientific understanding. Non-experimental research often identifies variables for experimental study. Correlational studies might reveal that certain personality traits are associated with job performance, leading to experimental studies that test whether training programs targeting those traits improve performance. Non-experimental research provides external validity for laboratory findings. If experimental research shows that a particular intervention works in controlled laboratory conditions, non-experimental research can examine whether it works in real-world settings with all their complexity and messiness. Non-experimental approaches examine phenomena in natural contexts, giving us insights into how processes unfold in real life, rather than in artificial experimental conditions. Non-experimental research tests the generalizability of experimental results across different populations, settings, and time periods. An intervention that works with college students in laboratory settings might work differently with working adults in real-world settings. Non-experimental research explores complex relationships that aren't suitable for experimental manipulation. The relationships between culture, family dynamics, personality development, and life outcomes are too complex and long-term to study experimentally, but they can be illuminated through careful non-experimental research. Finally, non-experimental research generates hypotheses for future experimental testing. By identifying patterns and relationships in naturalistic data, we can develop theories that can then be tested more rigorously through experimental approaches. It's helpful to think of research designs as existing on a continuum rather than in distinct categories. On one end, we have experimental approaches with high internal validity. They're great at establishing causation because of manipulation, random assignment, and controlled conditions. On the other end, we have non-experimental approaches with high external validity. They're great at describing real-world phenomena because they study natural groups in real-world contexts. This isn't to say that experimental research has no external validity, or that non-experimental research has no internal validity. Rather, it's about emphasis and trade-offs. Experimental research prioritizes internal validity, the confidence that our independent variable really caused changes in our dependent variable. Non-experimental research prioritizes external validity, the confidence that our findings apply to real-world situations. Experimental research allows causal conclusions, while non-experimental research typically allows descriptive and correlational conclusions. Both types of conclusions are valuable for different purposes. The key insight is that neither approach is inherently better than the other. They serve different purposes and answer different types of questions. The best research programs use both approaches strategically to build comprehensive understanding of phenomena. Non-experimental research isn't a single approach. It's a family of related approaches, each designed to answer different types of questions. Descriptive studies ask what exists or occurs. These studies aim to characterize phenomena, document their prevalence, or describe their characteristics. Examples include epidemiological studies that document disease prevalence, educational studies that describe current teaching practices, or psychological studies that characterize the symptoms of mental health conditions. Correlational studies ask, how are variables related? These examine associations between variables without manipulating them. Examples include studies examining the relationship between personality traits and job satisfaction, or between social media use and mental health. Comparative studies ask, how do groups differ? These compare naturally occurring groups on various outcomes. Examples include comparing academic achievement across different school districts or comparing health outcomes across different demographic groups. Predictive studies ask, what predicts outcomes? These identify variables that can forecast future events or conditions. Examples include studies that identify risk factors for disease, or that develop models to predict academic success. Survey research asks, what do people think, feel, or do? These studies gather information about attitudes, beliefs, behaviors, or experiences from representative samples. Observational studies ask, how do people behave naturally? These involve systematic observation of behavior in natural settings, such as studying social interactions in workplaces or learning behaviors in classrooms. Planning non-experimental research requires careful attention to these key elements. Unlike experimental research, where the structure is somewhat predetermined by the experimental design, non-experimental research requires more upfront planning to ensure valid and interpretable results. First, clearly define your research questions and objectives. Because you won't have the control that comes with experimental manipulation, your research questions need to be precisely focused and realistic about what can be concluded from non-experimental data. Second, identify key variables and their measurement. You need to think carefully about how you'll operationalize your constructs and whether your measures are valid and reliable across the populations you're studying. Third, consider potential confounding variables. This is crucial because you can't control these variables experimentally, so you need to measure them and account for them statistically. Fourth, select an appropriate sampling strategy. Your sampling approach will determine who your results apply to, so this decision is critical for the external validity of your findings. Fifth, choose appropriate data collection methods. Will you use surveys, interviews, observations, archival data, or some combination? Each method has strengths and limitations that need to align with your research questions. Sixth, plan your statistical analysis approach. Non-experimental data often requires more sophisticated statistical techniques to account for confounding variables and to avoid overinterpreting correlational findings. Finally, acknowledge limitations in interpretation. Build into your research plan a realistic assessment of what conclusions you can and cannot draw from your non-experimental data. While non-experimental research has inherent limitations, there are different strategies that you can use to enhance the quality and credibility of your findings. Use multiple measures of key constructs. If you're studying job satisfaction, don't rely on a single self-report measure. Use multiple indicators, perhaps including supervisor ratings, behavioral indicators, and physiological measures. Include control variables in your analyses. Measure and statistically control for variables that might confound your results. This doesn't eliminate the possibility of unmeasured confounders, but it reduces the likelihood that your results are explained by variables you can anticipate and measure. Employ longitudinal designs when possible. Following participants over time helps establish temporal sequence and provides stronger evidence for causal relationships than cross-sectional designs. Triangulate with multiple data sources. Combine self-report data with observational data. archival records, or reports from multiple informants to get a more complete and accurate picture. Use large, representative samples. Larger samples provide more statistical power and better generalizability, while representative sampling enhances external validity. Apply appropriate statistical controls through techniques like multiple regression, propensity score matching, or instrumental variable analysis to account for selection effects and confounding. Finally, be transparent about limitations. Acknowledge what your study can and cannot conclude, and discuss alternative explanations for your findings. This transparency actually enhances, rather than undermines, the credibility of your research. Let's conclude with the key takeaways from today's lesson. First, non-experimental research addresses questions where manipulation is impossible or unethical. Far from being a second-choice method, non-experimental research is often the only appropriate way to study important phenomena. Some of the most important questions in psychology, education, health, and social sciences can only be addressed through non-experimental approaches. Second, non-experimental research provides high ecological validity but limited causal inference. This trade-off is important to understand and accept. We gain real-world relevance but sacrifice some confidence in causal conclusions. Third, non-experimental research is essential for studying naturally occurring phenomena. The complex, multifaceted nature of real-world phenomena often requires the observational approach that non-experimental research provides. Fourth, non-experimental research complements experimental research by providing real-world context. The two approaches work together to provide comprehensive understanding. Experiments establish what can happen under controlled conditions, while non-experimental research shows what does happen in real-world conditions. Fifth, non-experimental research requires careful attention to confounding variables. This isn't a weakness, it's a design requirement that, when handled properly, leads to more nuanced and sophisticated understanding of complex phenomena. Finally, multiple strategies can enhance research quality and validity. While non-experimental research has inherent limitations, thoughtful design and analysis can produce findings that are both credible and useful. Non-experimental research isn't the easier path, it's a different path that requires its own expertise and sophistication. When done well, it provides insights that experimental research simply cannot provide. Thank you for your attention, and I look forward to exploring specific non-experimental designs in our upcoming lessons.